All right, so we're going to talk about projectile motion. And just to recap what we talked about in class, there are four assumptions we're going to make. And these four assumptions are we're going to assume gravity is constant, it's down, is equal to 9.8 in all areas of this projectile. We're going to ignore the effects of air resistance. We're going to assume the Earth is flat, and we're going to assume that the projectile has the same vertical plane. And just to refresh what we were talking about, we're going to split the x and the y axis. So if you notice, these are the velocity vectors, and at each point in the trajectory, the velocity has a different, it's moving in a different direction, right? These arrows sort of represent where the velocity of the object in real time. And if you look at breaking it up into the x and the y components, you'll see that the x component remains constant. This one is here beside that. The x component is constant the whole time. It doesn't change. There's nothing affecting the motion or the velocity of the ball or whatever the projectile is in the horizontal direction. But in the vertical direction, it starts out kind of moving fast upward. You can see gravity slowing it down, stopping at the top. Then it turns around and it moves in the opposite direction. So gravity is always acting. It's always acting down. And it's 9.8 meters per second squared. The orange arrows basically follow the exact same trajectory as a projectile that's just thrown straight up and straight down. Okay, and we're going to look at these vectors, and we're going to break them up into their horizontal and vertical components whenever we solve these problems. So coming up, we're going to, in the next few videos, we're just going to go through the examples one by one. So follow the next videos for a detailed solution to all these problems. Okay?